Now, comparing the voltage regulators or the kinds of regulations, there are two kinds of regulations. One is the line regulation and the other one is the load regulation. So as we were talking about that, how do we compare the kinds of regulations or what kind of regulator is better? So for that we need these two kind of methods, line regulation or load regulation. So first of all, let us see a circuit that can be actually working as a regulator. First, as we said, that any circuit that has this kind of overview, that has this kind of structure, that has this diode, and we take the output from the diode, it actually works kind of as a regulator. So this here, this circuit is a regulator, and then it is connected to a load. And now we are trying to see the kinds of regulations that we have talked about, line regulation and load regulation. So first, line regulation actually works with the change in line. That means if there is any change in the line voltage or the supply voltage, then how does the output voltage act with the change? Does it remain same, or how does it change with respect to the change in the input voltage? So it means that if I change the input voltage by a certain amount, I am trying to see if my output voltage is changing. If it is changing, then at which rate? Means if I change the input by say 1 volt, then how much my output is changing. Is it changing too much? If it is changing too much, then I can say that it's not actually doing a good job as a regulator, because it is supposed to keep the output at a certain level. But if it is a very low value, say in millivolt ranges, which is typically the values of the line regulation, millivolt per volt, we are going to see it ahead. So then we can say that the change in the output is in the millivolt range with respect to volt ranges. So it is actually working quite perfectly. So now we are going to see how this thing actually works. So we have talked about line regulations. What about this load regulation? So load regulation is when I am connecting a load with this circuit. Obviously, this is going to draw some current, that is, we say IL. So as this current is drawn from this circuit, there is some changes at the output. So because of this drawing of current, so how this works means how the load current or the change in this load current affects my output voltage. That is what I'm trying to see in load regulation. So first, very simple, we are trying to write the node equation at the node VL, because this VL is my output and this is actually the same node. So this VL is actually my V output. So if I write my node equation at VL, I'm going to get VL minus VI divided by R as the first term, and then VL minus VD divided by small r second term plus IL. So I have written the equation in such a way that all three of my currents, all the three branches are going outwards. So the summation is going to be 0. And then pretty simple, if I simplify it, then I am going to get an equation like this. That VL, that means my output is equals to small r divided by capital R plus small r whole into V input minus capital R into small r divided by capital R plus small r whole into IL minus capital R divided by capital R plus R whole into VD. So now from this equation, I am going to explain line regulation and load regulation. Firstly, for line regulation, I have already explained a bit that here we are trying to see the change in the output voltage with respect to the change in the input voltage. So del VL, that is the change in the output voltage, and del VI, that is the change in the input voltage. So this is kind of a differential form like calculus as we have studied before. So change in the output voltage with respect to change in the input voltage means above we have this change in output voltage, and divided by we have this change in input voltage. And this comes from this equation actually. If we differentiate, if we take like ddvi of dVL, then we actually get this, that del VL divided by del VI equals to small r divided by capital R plus a small r. This small r, as I have said before, is the equivalent resistance of the diode in our CVD plus resistance model. And this capital R is the input voltage of this circuit. So this change is actually related to this small r, so of the diode. It is dependent on that. And now load regulation, as I have tried to say before, that it tries to measure the change in the output voltage with respect to the change in the load current. Means whenever I'm trying to connect a load with this circuit, it is going to draw some sort of current, and for that the voltage at the output is going to change. So del VL, change in the output, with respect to del IL, that is the change in the load current, equals to, it also comes from the derivative of this equation. If you take dVL divided by DIL, if you take this differentiation, you are going to get this minus capital R into R divided by R plus R. So what does this minus sign mean? We did not have it in our line regulation. So why do we have this in our load regulation, and what does this minus sign actually mean? So it means that if our load current changes positively, means if the load current is increased, then our output voltage is going to be decreased. Means minus means, negative sign means the relation between these two elements, that change in output voltage and changing input voltage, are opposite. Means if one increases, the other decreases. Means if our load current decreases, then our voltage, change in output voltage, it increases. And if this del IL decreases, then this del VL increases, and if del IL increases, then del VL decreases. So if del IL goes up, then del VL goes down. If del IL goes down, del VL goes up. Pretty simple. So it means if change in load current increases, then change in output voltage decreases, and vice versa. So this is overall the expressions of line regulation and load regulation that we are going to use in our maths and other concepts. So, and some pretty simple terms that are going to come in handy. The units of this regulation. So line regulation unit, we can see that line regulation is the ratio of two voltages, del V output divided by del V input. So this is going to be some sort of voltage by voltage. So typically it is measured in millivolt by volt, because the output change is typically occurring at millivoltage ranges, and the input change is normally measured at voltage ranges. So this is the typical unit of line regulation. And for load regulation, we can see that it is the ratio of a voltage and a current, output voltage divided by del IL. So this is also measured in the output voltage changes in terms of millivolts, and the load current change is measured at milliamperes. So this unit is normally millivolt divided by milliampere. So this is typically the unit. So now, how do you quantify this regulator values, this regulation values, and how can you say that if our regulator has a value of say 5 millivolt per volt and another has say 4 millivolt per volt line regulations? So we can see that from the units, you can say that these are values of line regulations, because just now I have said that millivolt per volt is line regulations unit. So how do you say which one is better? So as I have said before, we want to keep the output voltage same. So if the output change of the output voltage with respect to the input voltage is low, it means that the output voltage has not changed much. It means that this, what does this two numbers mean? So 5 millivolt per volt means that if our output was previously at say 5 volt, then now if the input is changed by 1 volt, then my output is going to be 5 volt plus 5 millivolt. And what does the 5 millivolt plus per volt regulator say? It means that if our output was say fixed at 5 volt and our input changes by 1 volt, then now my output is going to be 5 volt plus 4 millivolt. So which one gives kind of almost same result as the output was previously? Obviously the second one, because it gives the change as 4 millivolt and this one changes by 5 millivolt, means it is deviated from the basic nominal value by 5 millivolts, and the second one changes only by 4 millivolts. So the regulator that has the regulation value that is lower, that is the better kind of regulator. So that is the one that you want to use when you are using regulators.